Welcome to APAC Data 2030 Summit. In this session, I'm going to talk about the future of data strategy in cloud. Let's have a quick introduction. My name is Faisal Hajazi. I'm head of cloud architecture and strategy with British American Tobacco. I'm based in Malaysia. I've been in the industry for 19 plus years. Prior to joining to BAT, I was with Microsoft and I was leading the data and AI technical sales across Asia. And before that, I have worked with an end user as well. I worked with banking and insurance industries. And I started my career in consulting. So not more on my introduction. Let's move forward to what we are here to speak about. All right. Data strategy. There are different elements of data strategy. Let's see. In what you see in this slide here, there are 6 different areas of a data strategy. And these different elements of data strategy are not new. And you won't see them unique or I have discovered something extraordinary. They are there. They are there from last 5 years, 10 years, 15 years probably, or more than that. But what has changed over the past at least 5 to 7 years, there's a huge shift in how do we overall design and build the data strategy, how do we build the data ecosystems, how do we build the data platforms. It has changed a lot. It has changed drastically, especially with the cloud and the edge. We need to look and rethink how we build the data strategy and when we build the enterprise data platforms. Right? Every data strategy starts with the business strategy and business alignment. A data strategy has no meaning if we do not have a business strategy aligned to it. Right? A data strategy is always built to support the business, overall business strategy and goals. Right? Data strategy should not be built isolated. Right? It has to be built understanding the overall ecosystem of an enterprise and the business goals and objectives of an enterprise. With that, what is different, right? So, thinking 5 years, 10 years before, the business alignment was maybe to understand, get access to data, get to access the clean data, get to access the data that they can use and they can make decisions. And the decisions could be 1 day old, 5 day old, a month old. So it evolved from a weekly, monthly, and daily reporting to getting an instant and online business data-driven decision. So these things have changed from a business alignment point of view. Similarly, from a data gathering, it has also evolved, data gathering process. So simply put in perspective, the data gathering process, when we started the data ecosystem, maybe many years back, we had the data marts. We evolved from data marts to data warehouses in a relational data store, Oracle, SQL Server, and so on. And then we moved to a batch processing, and then batch was also T+1, T+2, T+7, and all the stuff. We process the batches, we get the data, we process it and store it, and we build some analytics on top of it. And then we moved from a batch to a mini batch and CDC model, change data capture, where we try to store data in a faster pace, in mini batches, maybe twice a day, right? Or in a CDC, maybe as soon as data has changed in certain databases. And from there we moved to a very recently now in a streaming ecosystem where we want to capture the data very fast as soon as it is generated. As soon as it is generated, we want to capture it. We want to take action on it. So we have evolved from a batch to a streaming data processing, from an ETL to an IoT-based data ecosystem. Right? In terms of technology, we have also evolved. We evolved a lot. We used to store the data. We used to have databases, relational data warehouses, and from relational data warehouses like Oracles again and DB2s and the likes of those, we moved to an MPP based data warehousing architecture. We thought, yeah, the MPP is a data warehouse where we can store all our data and we get all our answers. Yeah, it was right at that point in time. They were doing the job what they are built for, be it Teradata, Exadata, and all of those ecosystems and engineered systems. But we evolved from it has a limitation, and we evolved from an MPP data warehousing architecture to an Hadoop-based architecture, and that was the answer. Hadoop is the answer for everything, right? And we thought we are going to dump all our data, relational data, unrelational data, which MPP and relational database cannot store. We can store all the data in Hadoop, and we'll get all our answers, right? And we realized that, no, what? Because of the cloud, there are limitations also in Hadoop ecosystem, and we moved to a data lake and so on. And we are still evolving. We are still evolving in that space. Technology is evolving. Technology is changing very, very rapidly. In last at least 2-3 years, you have seen a huge change in the technology, especially in databases and data warehouses. Similarly, in data insights, we have moved from a simple dashboarding to a real-time AI embedded analytics. And how do we design those AI embedded analytics? How do we do the governance of not just the relational data stores, but governance of unrelational data, governance of the big data? How do we make sure that the data access is stored from multiple different sources, internal, external? How do we make sure security, compliance, and all of those areas are part of the governance? And they are key, because the volume we are storing, the data variety we have, and access to data of different sources, the governance becomes more important, and the tools and technology related to governance become more important. And finally, the people in the process are always part of this ecosystem. It has also changed from being a one data team to a multiple different data teams. We used to have one BI team or data warehousing team, and now changing from that to being a multiple different teams within our ecosystems, and data storage team or analysis team, and data science team, and data processing team, and so on and so forth. All of those elements are critical to any data strategy. And we need to make sure that we look into this lens of saying that all of those elements are present and are important when we decide and build the data strategy. Other area within the data strategy which is important is how do we make sure that we have defensive as well as the offensive strategy. It's not or, it is maybe and or. In certain cases, for example, if we are working for a banking or regulated industry, we may need to have certain data elements which are more defensive, which are more secure, which have more privacy in terms of regulatory compliance and governance. So we need to build a strategy which are aligned to a defensive data strategy. But at the same time, in other industries, we need to make sure we have competitive advantage. And I'm not saying banks doesn't have a competitive advantage, but there is a data element in almost many of the regulated industries where you need to store the data in a more secure, more regulated manner. Where in other industries, you have liberty to kind of play with the data and have more competitive advantage in terms of analytics you build on the market. So control data management and flexible data management. Again, in a defensive strategy, we build more of a control data management. That when we build our data ecosystem, we give access to certain set of data to certain people. We make sure that those people which have the right access can access the right data only, and they don't have access to all of the data. In a flexible data management, we have multiple different data teams. For example, data science team which want access to raw data, and we give them the access to raw data, making sure that compliance and regulatory and governance is taken care. And similarly, we were thinking of building a single source of a truth to a multiple version of a truth. So we still, does it mean single source of truth is not important? We don't need a single source of truth. We do need a single source of truth. We need a customer master, right? We do need a product master, and we do need an inventory master, and so on and so forth. Those are the master data stores master data tables that we still think are the single source of truth for enterprise. But at the same time, we build multiple versions of that single source of truth, because there are different teams who want to access the data in a different way, be an data engineering team or data science team or the analytics team. So we build this multiple version of truth to give them access to their teams. Not only those teams, but within the different domains. We want to give access to a marketing domain, a finance domain, and an engineering domain, so that they have that data and the data what they access is a version of a truth, right? So, and that's also critical when we build our data strategy. All right, let's move forward. What's driving? There are five, for me, there are 5 different trends which are driving this data strategy, and especially data strategy in cloud. We start with the AI, right? In reality, AI is already at work all around us. It's impacting everyone from the way we search in Google or any search engine, or buying behavior, how do we buy stuff, or deciding our next holiday. So all of those are anyways impacting our day-to-day behavior. How do we interact, and how do we interact with different systems within the organization, outside the organization. At the same time, if you see that less than 75% of enterprises will shift to an operational AI, from an analytical AI to an operational AI. So people are more now thinking that how do we get an operational AI capabilities, which means to have a real AI-enabled application systems which can take decisions based on AI models at real time. So why is it important? It's also important. The other area of building this AI is how responsible we are. We need to make sure that there's a security, there's a privacy, and there is a fairness when we build these ecosystems. Keeping all of these trends in mind, we need to, when we start building our data ecosystem and data strategy, we have to think of those aspects. From there, we look into the dashboards. So what's happening in the dashboard? They are becoming obsolete, right? If you see around your organizations, how many people are using week-old, month-old dashboards? It was a case many years back, but now people want to, the business executives, the analysts, they want to access the data which is fresh, which is maybe, if not real time, but at least not a day old or 2 days old, with maybe a couple of hours old, and they won't take a decision based on those data elements. And they only don't want to have a dashboard which tells them what has happened in the past, but they want to have a capability which will tell them what's happening in the future, what will happen next day, what will happen next month and next year. So these capabilities has changed and evolved, and there are different technology and tools which have come into place in at least last 5 years, that the traditional dashboarding and reporting capabilities has become obsolete now, right? If you see here that 50% of unused dashboards, and I'm sure if you look into your organization and see how many people are using old dashboards, you realize that 50% may be a smaller number. There are more people who are not using these dashboard capabilities at all, right? Similarly, if we move forward, then you see the other area is X analytics. So what is X analytics is, it's basically about extracting maximum value from all of our data as soon as possible. So we analyze the data. When we have this data, our data scientists have access to the data whenever they want to have access to data. They have access to data to do the analytics. So to make a decision. So the idea of it, X analytics is essentially encompasses everything, structure, unstructured data, gathered and stored in a way, and processed in a way, and stored in a technology elements and stacks that's accessible to a different data domains, to a different data teams, as and when they need it, right? So it's like a Gartner coined this term as an X analytics, which is like an umbrella term of where X is a data variable from a range of different structured and unstructured data elements. To do what? To do maybe in text analytics, to do a video analytics, to do an audio analytics, or to do an build any machine learning algorithm, to create any model for any particular business use case. So all of those are kind of combined together in this term called X analytics. So when we build our, these are things which are changing the way how we design our data ecosystem, how we design our data strategy moving forward. Now, all right, so let's move forward. Multi-cloud, right? I would say multi-cloud is the way. I've been in industry, in a cloud industry for at least 7-8 years now, and I have seen, I worked with multiple different large organizations, Fortune 50, Fortune 100 organizations, and I've seen that growth in the cloud is like this is the #1 key priority for all our CIOs. That they want to move their legacy on-premise infrastructure to the cloud, and at the same time, when they move to infrastructure cloud, they realize that we need to have a strategy around this cloud. We need to have. I'm not talking about the entire cloud strategy here. I'm talking just one element of a cloud strategy, which is a multi-cloud strategy. So they realize that we need to have multi-cloud strategy. There are multiple reasons to have this multi-cloud strategy. By 2020, a public cloud services will be estimated around 90% of data and analytical innovation. So most of the data, if not all, 90%, almost all of the innovation is going to happen in the cloud. They are born in cloud ecosystems, born in cloud data warehouses, analytical platforms, AI, machine learning platforms. So those platforms are built in cloud. And also at the same time, why multi-cloud? Because each cloud providers, the big ones that we know of, Azure or AWS or Google Cloud or Elite Cloud and all of IBM and all of those guys, most of them, at least top 3, have the capability, but we want to make sure we get the best of breed capability from those cloud providers. We don't also want to have vendor lock-in. If you go with a single cloud provider, that may be a vendor lock-in with them, and there are elements of negotiation, there are elements of flexibility which we lose. There are also compliance. There's the other area that we want to make sure that we are compliant. There's also HADR capabilities that we want to make sure that we have, and we are not dependent on single cloud providers. And so this is a broad topic, but the cloud is the other, multi-cloud is the other area which is impacting huge data and AI space. And finally, last but not least is data marketplace. So data marketplace is again, they are growing a lot. If you see last at least 5-7 years, the data marketplace has emerged in a way because of the growth of the data, because of growth of big data, because of growth of the IoT data, streaming data, relational data. All of that data has grown so much that data has become so important, and data is now available for us, not internal data but also the external data. And you will see that because of this availability of data, by 2022, next year, 35% of the large organization will be either selling the data or buying the data. So there's this ecosystem building where organizations realize that they can monetize this data. They can monetize their data, which is possible to sell securely, easily, to a different organization, or to buy a data because of some competitive advantage from a different organization, so that we build our machine learning algorithm, we build our AI models, we build our analytics based on not just internal data but also external data sources. So this is growing a lot, and this is changing how do we design our data strategy. Let's move forward. So there are some principles that we should keep in mind when we build this strategy. So these principles are, number 1, multi-platform architecture has become norm. So I did mention this. What does this mean? Is that initially we thought that there's going to one data platform, there's going to only one platform, which is that data warehousing or big data, or there's just one platform which is data lake or just an HDFS Hadoop systems. They are going to solve our problem. But we realize that that's not the case. It's changing, and multiple platform architecture is becoming a norm. And we have multiple different platforms for a relational data store. We have multiple different platforms for data lake kind of capability. We need a store for ML processing. We need a store for analytics. We need a store for storing data for certain use cases in different format, right? Images or texts or videos. So because of the different varieties of data, we realize that multiple platform architecture is becoming a norm, and having that multiple platform architecture is another key area that we need to consider. The other area is that having the data analytical capability, flexible data analytical capability. What does this mean is essentially a data ability to access the data while it is streaming as soon as it is stored, accessing from a different use cases. So we need to have a capability in our data platform, a strategy in our data platform when we build a data estate or data architecture, that it is flexible. It's flexible enough for a different base of users to access the data for different use cases. Right? So these flexible analytical capabilities are becoming another norm, and we are not limited to one particular tools or technology stack. So we need to have flexibility in terms of what tools and technology we use for a different analytical purpose. So maybe for an AI embedded system is a different use case and different technology stack. For an real-time dashboarding is a different technology stack. For a data science platform, a different technology stack. So the different areas that we need to make sure that we have that capability, right? All right. So then architecture is constantly changing. So yeah, it is changing. It's changing how we source the data, how we stream the data, how our data coming from an IoT device and sensors, our business data coming from business apps. Because of the different data sources coming from a different sources, different varieties, we need to have our architecture which is flexible enough. It's flexible enough to adopt a change as and when it happens. When we discover any new use case and we realize that this use case needs any different technology stack and elements, it should be flexible enough to adopt those changes. And again, all of these elements are critical when I'm saying is data storage in cloud, and this is possible in cloud. And all of these flexibility in an architecture platform, flexibility in an analytical capabilities, or in having the architecture which is very constantly changing, is not possible being in on-premises world. It's only possible when we are in a cloud world, right? Similarly, from moving from a data lake to a data warehousing, a data lake and data warehouse work together. They are not. It's not one solution which solves all the problems. So it's not data lake which solves all the problems, or it's not data warehouse which solves all the problems. Both works in tandem, both works together. There is a use case that is a data stores, there's a relational data which stores on a relational data warehouse, and there's a data we need to store in data lake. And we move actually beyond that. We move beyond from just a data lake to a data mesh architecture. So what's data mesh? So I will have one slide on data mesh architecture, but it's really not about a technology stack. Data mesh is not about technology. So data mesh approach is in the sense is a domain-based approach. Is like for example, a data mesh approach is a single domain becoming a mini enterprise, like how and getting the ability to control and self-service all the aspects of the data and data science projects, and having the ownership, having the responsibility of that particular domain within that ecosystem. So you will have multiple domains who are having their independent data mini enterprises, ownership of the data, and accessibility of the data. Right? So these things are again changing how we build the data ecosystem. And then you will see that this shift, what I saw in the previous slide, the principles. In principle, the shift you will see is obvious in the technology stack. There's a huge shift in technology stack from a traditional data warehouse to a cloud data warehouse. You will see that there are cloud data warehouses that evolve, for example, Snowflake, Azure Synapse, or BigQuery. recently Snowflake becoming one of the big cloud provider, and built-in cloud data warehouse, and the ability, the capability they have is kind of shaking the other players in that industry. But yeah, there is a shift from a traditional data warehouse to a cloud data warehouse. You are born in the cloud, built in the cloud. There is a change. How do we do the data warehouse, data lake to a data lake house architecture? Now, not only the data lake, but a data lake house architecture is becoming more of a capability that we want to explore. It's an approach which acknowledges the idea that making a one-size-fit-all approaches to analytics eventually leads to a compromise. It is not simply about integrating a data lake with a data warehouse, but it's rather about integrating a data lake, a data warehouse, and a purpose-built stores for different use cases, and have a unified governance around the data. So that's from moving a data warehouse, data lake to a data lake house approach. And then if you move forward, you see from I discussed earlier, from a batch processing to streaming processing. And there are streaming on the right side. If you see in this chat, there are different streaming platforms now becoming more prominent. Spark streaming, Confluent has come up with the Kafka streaming. There is a cloud-based, cloud-native streaming, for example, Azure IoT Hub, and similarly IoT Hub in AWS, Event Hub, and so on and so forth. Streaming platforms purposely built within the cloud, be it an AWS, Azure, or Google Cloud. They have their own streaming platforms, and these platforms are becoming very mature, and a lot of organizations are using these as a default data sourcing capabilities. Cloud to an edge cloud, another area which is very critical in understanding the edge cloud. So it makes it possible to decide faster, particularly in a low bandwidth situation. For example, edge becoming critical for us to take any action in a cloud. If the bandwidth is not enough or the network is down, so we need to make sure that in certain use cases we take action wherever we are. So edge is becoming more critical. For example, if we need to take a decision, a split-second decision in an autonomous car, whether I should give a brake or not, we cannot be dependent on moving to the cloud, taking a decision in cloud and coming back, but it has to have a capability within that car which can make a split-second decision, and build that capability within an edge platform. And having that edge capabilities using containers or other different systems, so that we can build those analytical solutions in a cloud and deploy in the edge. And there are different vendors in AWS and Azure and all of the guys which have this capability to build those platforms. And then monolithic data warehouse and polyglottic persistency. What does this mean again? Having the purpose-built data store for a purpose-built platform. So, for example, if you want to store a JSON, you need to store in a JSON database, be it the Cosmos database, be it the Mongo database, or so on. So they are purpose-built for storing the JSON NoSQL data store. So you need to have a data store which stores the NoSQL data. Be it a graph data, you need to have a data store which stores the graph data. So you cannot put the graph data, JSON data, NoSQL data in a relational data store. It doesn't make sense. It doesn't work out, and it doesn't work out until now. And hence, if you see all the different data stores available in market today, be it in a cloud or a native or an open source one, they are purpose built for the different use cases. So when we build our strategy and architecture, we need to make sure that we have that. We had that concept in mind to build that purpose-built data stores. And lastly, the analytical AI to an operational AI. So there are different operational AI tools which are available, which are becoming very mature now, and using those tools, having those capabilities within our ecosystem are becoming more important for our organization. So all of these architectural shifts are driving us all towards the cloud. If you see from top to bottom, it all happens within the cloud. So the clouds are becoming very, very critical, and data ecosystem within the cloud are becoming the default norm. All right, so as almost I'm with just 2 more slides done. So I talk about the lakehouse architecture. This is how AWS built their lakehouse architecture. Customers are building databases, data warehouses, data lake solutions in isolation from each other, right? Each having its own specific data integration, store management, and governance layers. Often they are disjointed, right? So the concept of data lake house is to build the data, to build that store, which is not really disjointed. It has a capability. For example, it's not just a data lake which doesn't have the edge capabilities. It should have an atomicity, consistency, isolation, durability. Those are the capabilities which we want to see in our data lake, and hence the data warehouse, hence the data lake house. There should be a way to enforce the schema and ensure the governance the way we reason with the data integrity. So they need to have a data integrity, they need to have a governance in place. So all of those elements, if you see from left, it's sourcing to governance to data cataloging, data transformation, and having multiple purpose-built data stores for NoSQL data, data warehouse, log analytics, big data, relational data, and machine learning data lake into one ecosystem is also becoming another way of looking how do we design how do we build our future data ecosystems, a lake house architecture. And again, Amazon, Databricks, Microsoft is coming up with these kind of solutions which are available for us. And the last slide for me for today's session is the data mesh. We spoke about a little bit about data mesh. It's like what's unlike the traditional monolithic data infrastructure that handles the consumption, store, and transformation and output of the data in one central data lake. A data mesh supports a distributed, a domain-specific, a data consumer and a view of data as a product. So how do you see data as a product? And you build a different data domains. You have a multiple. I have seen there are two federated and governed data mesh. And these are different types of how do you build a data mesh. But essentially, what you do is you see data as a product. You have a data domains which you build around that. So this is the way when we build the data ecosystem in a format where you have multiple different data domains which has the within themselves an enterprise and has capability to build the data storage, data processing, data analytics, machine learning, and are also responsible what they build, and also not only what they build independently but have the ability to share the data across enterprise, have the common governance, have the common model in place, in the sense that they follow the enterprise standards, enterprise architecture processes, and governance which are decided based on the enterprise architecture policies. So essentially the principles are data oriented and decentralized data ownership of architecture, decentralized but then data ownership and then of the particular domain architecture. Consider data as a product, a self-service infrastructure platform within each domain. Within each domain, you have a self-service integration platform. It could be a same product stack that we use within the domain, or it could be there are different domains here, right? So you can have a same product sets you use within the domain, or you can use like different product set, but you have a centralized governance, a centralized framework, and centralized process. And then when I say federated governance within the domain, so federated governance within the domain. So each domain have their own governance. How do they manage the data? How do they access data? How do they store the data? How do they publish the data? So there's a lot to say about data mesh, but with a limited time, this was the last slide of my presentation. Thank you for listening me and having me on Data 2030 Summit. I really appreciate everyone who is here present listening to this conference. Thank you very much, and I really appreciate it. This is my contact. If anybody wants to reach me or contact me, more than happy with that. With that, thank you, and have a good day. Bye-bye.